Let us look at proposition number 44 of book 10 of Euclid's Elements. The proposition says a second medial straight line is divided at one point only. Let's see how we can prove that. Let AB be a second bimedial straight line divided at C. So let me bring in C such that AC and BC are medial straight lines. AC and BC are commensurable in square only. AC by BC is a medial rectangle. C is the only point at which AC and BC will have all these properties. AC cannot be equal to BC since AC and BC are not commensurable in length. They are commensurable in square only. So again, using proof by contradiction, we will prove this. If possible, let AB be divided into its terms at D such that AC is greater than BD. Then AD square plus BD square is going to be less than AC square plus CD square. Here, AD and BD are such that they will have the same properties as AC and BC. That is, AD and DB are medial straight lines. They are commensurable in square only. And AD by DB is a medial rectangle. So to prove this, let's set out a rational straight line EF. So let me set up that EF. And remember, I introduced a D. So let me bring in D as well. Apply to EF a parallelogram, more specifically a rectangle, EK equal to the square on AB. So again, we know how to do this. So this rectangle area is equal to AB square. Now subtract parallelogram EG from EK equal to AC square plus BC square. Again, let's subtract it. So EG is the parallelogram equal to AC square plus BC square. The remainder, since we have subtracted EG from EK, the remainder HK will be equal to 2 times AB by BC. Because remember, the whole thing is AB square. And EG is AC square plus BC square. So that means the remainder will be 2 times AB by BC. Now subtract parallelogram EL equal to AD square plus DB square from EK. Just like we did for AC square plus BC square, similarly we do it here with respect to AD and DB. So let's bring in EL. So here EL is equal to AD square plus DB square. That means the remainder MK is equal to 2 times AD by DB. Right? Remember, EK is equal to AB square, which can be written as AD square plus DB square plus 2 times AD by DB. Now, since AC square and CB square are medial, right? Which implies EG is medial. EG is applied to a rational straight line EF. So a medial line is a medial rectangle is applied to a rational straight line EF. That means EH is rational and incommensurable in length with EF. EH is rational and incommensurable in length with EF. Similarly, HN is also rational and incommensurable in length with EF. AC is incommensurable in length with BC. Why? Because it is commensurable in square only. So in length, it will be incommensurable. We can write this as a proportion. AC is to CB is equal to AC square is to AC by CB. Since AC is incommensurable with CB, that means AC square is incommensurable with AC by CB. AC square plus CB square is commensurable with AC square because they are squares. AC square AC and BC are commensurable in square. So that means their sum will also be commensurable with one of the squares. 2 times AC by CB is commensurable with AC by CB. Pretty straightforward this one. So which means AC square plus CB square is commensurable with AC square. 2 times AC by CB is commensurable with AC by CB. But AC square is incommensurable with AC by CB. That means we can say AC square plus CB square is incommensurable with 2 times AC by CB. Now, what is AC square plus CB square? That is nothing but EG. AC square plus BC square is nothing but EG. And 2 times AD by BC is HK. So we can say EG is incommensurable with HK. Means if the rectangle EG is incommensurable with rectangle HK, that means EH is incommensurable with HN. EH and HN are rational straight lines commensurable in square only. And if we add it up, we get EN. So that means EN is irrational straight line divided at H, what is called as binomial. Similarly, EM and MN are also rational straight lines commensurable in square only. And EM plus MN is equal to EN is a binomial straight line divided at M. So EN is a binomial divided at different points H and M. Now, EH is not equal to MN. EH is not equal to MN. Since AC square plus DB square is greater than AD square plus DB square. So AD square plus DB square is greater than 2 times AD by DB, which basically implies that EG is going to be much greater than MK. Here we have already seen this. AD square plus DB square is less than AC square plus CB square. Or if we reverse this, it becomes AC square plus CB square is greater than AD square plus DB square. AD square plus DB square, which is EL, is greater than 2 times AD by DB, which is nothing but MK. So EG is much greater than MK. And if EG is greater than MK, that means EH is greater than MN. And if it is greater than MN, that means it is not equal to MN. Therefore, a second medial straight line is divided at one point only. So that is proposition number 44 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.